Hi, folks. Welcome to the Microsoft Edge State of Web Developer Tools session at Build. My name is Zohar Gediali, and I'm a program manager on the Microsoft Edge DevTools team. And I'll be joined later in the session by Rob Paveza, who's an engineering manager also on the DevTools team. We are so excited to talk to you today about the latest updates and advances to tooling for web developers. You can think of this session as an iceberg. We're going to start with the simplest and surface level changes to Microsoft Edge for developers, and then dive into some memory and performance investigations before going even deeper into the web platform, taking a peek under the hood of how we apply source maps with the ultimate goal of helping you make your web content fast. Let's start with how can Microsoft Edge help developers? In this section, we'll introduce you to the Json viewer, a new experimental feature in the browser. We'll provide a brief overview of the DevTools and conclude with a tour of Focus Mode, an inspired and refreshed design take on the DevTools interface. You may have used in the past browser extensions or other tools to inspect JSON, but you won't actually need any of those solutions anymore because of Microsoft Edge's new built-in JSON viewer. In order to demo the JSON viewer, which is currently an experimental feature in Microsoft Edge, let's open the Edge browser and navigate to Edge Flags. In the Search Flags field, type in JSON viewer and set this flag to Enabled. This will force you to restart the browser, which we'll do quickly. And now, when we navigate to any URL that returns a JSON resource, like this network request, it'll load directly in the browser in the JSON viewer. This also works for any JSON files you might have on disk. You can see that the JSON is formatted and color-coded as you might expect from your text editor, and you can also turn on code folding. Select the gear icon and check the code folding checkbox, and this allows you to expand and collapse individual objects and arrays within JSON, making it easier to parse large objects. In addition to the JSON viewer, Microsoft Edge has built-in web development tools that we call the Microsoft Edge DevTools. It's a set of tools that appear next to the rendered web page in the browser and provide a powerful way to inspect and debug web pages and web apps. As a non-exhaustive list, you can use the DevTools to inspect, tweak, and change the styles of elements in the web page using live tools with a visual interface, inspect network traffic and see the location of problems like resources that fail to load, and debug your JavaScript using breakpoint debugging and with a live console. And there are hundreds of other things that you can do with the tools as well. And with all of that power comes complexity. So let's say that on any given day, this is what your DevTools UI looks like. We have a top bar of what we'd call our primary tools. And then we have a bottom bar that we call the drawer with even more tools here. You know, there's actually 33 tools inside the DevTools, and they span the entirety of the web platform. There's so many different tools and so many different things that all of those tools can do, so it can really quickly get overwhelming and make it hard to learn about features or even just remember where certain things are. And that's why we introduced Focus Mode. Focus Mode is meant to be a breath of fresh air. It's all about simplification. But just because we've simplified the DevTools and hidden some lesser used tools doesn't mean that we've compromised on any part of our robust feature set. Focus Mode is designed to hold only the tools you want to see to help cut down on all of that noise. However, it's fully customizable, so you will have access to all the powerful niche tooling features you had before. Let's take the tour. Welcome to Focus Mode. The top part of the UI is what we call the activity bar, and the activity bar holds all of your primary tools. These are the tools you're going to use every day that you always want to see. Now, I mentioned how customizability is built into this refreshed UI. So in addition to moving the dock location of DevTools, you can also customize the positioning of the activity bar. If you like the older DevTools UI and you like the horizontal toolbar, you can leave the activity bar in this orientation. However, if you like the way VS Code is organized instead, you can move the activity bar to a vertical orientation. I love vertical tabs in Edge, and I like having a vertical activity bar as well. Now, I mentioned all 33 tools are always available. You can select the plus button in the activity bar to see a list of all the tools, and you can add them whenever you like for however long you like, and remove them as needed from the activity bar. Now that's just the activity bar. Let's take a look at Quick View. The Quick View allows you to look at two tools simultaneously. Let's say, for example, that I'm looking at some network requests in the network tool in the activity bar, and now I want to modify the user agent string in the network conditions tool. I can add the network conditions tool to the Quick View. We support Quick View in a horizontal orientation at the bottom of your screen, but you can also move Quick View to the right if you have more horizontal space and want to see your tools directly side by side. You can also expand and collapse the Quick View in its entirety for when you just want to focus on the tools in your activity bar. Alright, that wraps up our tour of Focus Mode. So I've been on the Microsoft Edge DevTools team since 2017, and every day I'm continuously surprised by the amount of depth to our tools and just how much there is to learn about rendering, performance, memory, and how we take in raw HTML, CSS, and JavaScript and output some of the most complicated and powerful web apps in the world. Let's dive a little bit deeper into some more technical areas of the DevTools. How can you use DevTools to help make your web content fast? Web performance is super important to us at Microsoft, especially since we build so many websites and apps, and we want to make them as fast as possible. Did you know that 40% of people abandon a website that takes more than 3 seconds to load? So in this section, we're going to focus on some new features in DevTools to help improve performance. So starting with enhanced traces, you may be wondering what they are and how they can help. Enhanced traces represent a powerful step forward that we have made in debugging and collaboration. Today, you can export data from various tools within DevTools, and these exported files are useful, but they often lack context. Here is an example of when DevTools is lacking context. I've navigated to bing.com and opened DevTools, and here in the Sources tool, you can see all of the files that make up bing.com. But now let's say that I go to the Performance tool and import a profile that I recorded against Bing some time ago. DevTools is going to do its best to map between the performance events that I imported and the JavaScript that is currently on the page. But assuming that some JavaScript has changed, the imported profile doesn't know about it or how to handle it. You could imagine this problem gets even worse when you import a profile for a completely different site than the one that you're currently on. These imports just don't have all the information that DevTools had at the time that they were recorded, and they become less useful the second that anything changes in your web content. Said another way, they become stale incredibly fast. Enhanced traces allow you to save as much DevTools state as possible, including references to source files, console messages, or DOM snapshots. Time to take a look at enhanced traces in action. Here you'll see that I'm on the Bing page, and I've opened the DevTools, I'm in the Performance tool, and I'm going to import a file. But instead of importing the typical JSON file that the Performance tool exports, I'm going to instead import a .devtools file. This is the new file format for enhanced traces from Microsoft Edge. And what you'll see happen here is DevTools will open in a new window because we're not attached to the page anymore. We're loading an entirely separate DevTools instance. The Performance tool is still going to load our performance profile as if we had just recorded it, because it contains all of the performance events. Now let's zoom into an event and select one. Here's something really powerful. We actually have the references to the source files preserved at the time of the recording. We can jump back to the Sources tool from the Performance tool, and we no longer have the problem of mapping between the page's current JavaScript and the JavaScript at the time of the recording. All the source file references are contained within the enhanced trace. And that's not all that we can preserve with enhanced traces. We can also preserve console messages and DOM snapshots. The console will be read-only because we are reading the log of messages that are contained within the enhanced trace. DOM snapshots let you see the state of the page at the time of the recording. The key benefits of enhanced traces are that even if server-side changes are made, you're preserving the state of your source code and the state of your web page. This means you can package and share self-contained DevTools instances when collaborating with your teammates or coworkers. Instead of, say, getting a rogue console error and then trying to show a colleague how you got to that state, you can instead export an enhanced trace and share the .devtools file with them, and the state will be preserved. Now that we've gone over what enhanced traces are and why we built them, you might be wondering how you can export one yourself. Enhanced traces are customizable, and you get to decide how much data and state you want to preserve when exporting a .devtools file. In this demo, we've opened DevTools and the Performance tool against the page that we're interested in profiling. But before we take the profile, let's go to DevTools Settings, and under Preferences, find the Persistence section. We need to check this setting, Export Enhanced Performance and Memory Traces, to start. And then we can optionally, depending on what we want included in the enhanced trace, include console messages, script sources, and DOM snapshots. Now with these settings enabled, let's go ahead and take a profile. So here you can see the profile we recorded, and when we go to export it, we get the .devtools file format, which again is the file format for enhanced traces. I'd now like to introduce you to the Selector Stats feature in the Performance tool. Selector Stats is a feature that is designed to help you understand what is happening during long-running recalculate style events in the Performance tool. During a recalculate style event, the browser is looking at all of your HTML elements and CSS rules and is saying, hey, something has changed. An element might have been added to the DOM. A pseudo class like hover might be applied. So let's figure out what style rules need to be recalculated. Let's demo the Selector Stats feature. In the Performance tool, we're going to open Settings and check the Enable Advanced Rendering Instrumentation setting. We need this checkbox in order to record the Selector Stats data. Now I'm going to go ahead and refresh the page and start profiling. Now that the profile has loaded in the Performance tool, rendering time is always shown with the color code purple. So we're going to select a section of the profile with a lot of purple time and find a recalculate style event. Selecting this recalculate style event is going to open up this bottom pane of the Performance tool, where we can see more info about this specific event. Now in the Selector Stats tab, we're going to get a table of selectors and the amount of time in microseconds that was spent on that selector. These other columns, reject count, match attempts, and match counts, all track the browser's rendering engine trying to understand how many elements the selector is applying to. One really useful thing we can do is sort by maximum elapsed time, and this is going to help us find the selectors that are taking the longest amount of time, that are contributing the most to this individual recalculate style event. And the best thing about having access to this data is that it is really easy to try changing something, like making your CSS selectors more specific or trigger less often, and then retaking the profile and seeing the actual improvement as a result of this data. We hope that enhanced traces and selector stats are features that you find valuable in your performance and memory investigations, and we truly want to collaborate with all of you incredible web developers out there to ensure that the web remains fast and accessible for everyone. I'd now like to turn the stage over to Rob, who's going to share some more advanced and powerful debugging techniques for memory and performance issues.
Thanks, Zohair. In this section, we're going to take a look at improving the speed and ease with which you debug by applying source maps in the DevTools to let you see as much of your original code as possible. We'll then conclude with some anti-patterns that slow down the web platform and might be contributing to bad performance of your web applications. Let's go. We can't really talk about our great advances in unminification without first taking a moment to talk about source maps. Source maps are a way to map your compiled, transpiled, minified, or web-packed production code back to the original source code that you wrote using VS Code or another text editor. For example, the TypeScript compiler optionally emits source maps when compiling TypeScript to JavaScript, or you could do the same in Webpack. In the last year, we've really worked hard to make your TypeScript workflow work great in Edge. Now, we've seen many solutions for getting your source maps from the TypeScript compiler and hosting them somewhere that Edge DevTools can load them successfully. Maybe you're shipping your source maps directly in line with your production code or side by side with it. Maybe you've spun up a server with an AAD managed identity for your engineering team to access all of your source maps and put in a custom source map URL comment at the bottom of your files. All of these are valid solutions, some that we've even seen internally at Microsoft for leveraging these source maps in DevTools. But Far and away, we recommend Azure Artifact Symbol Server, which provides security and privacy and is easy to configure via PATs and pipeline tasks. However it is you choose to publish your source maps, once DevTools can load them, we've landed some awesome features to leverage them and apply them that we're excited to share with you today. And just going back to something Zohair demoed earlier, all of these features work seamlessly with enhanced traces as well. You can debug faster than you ever have before using original file and function names from your source code, and you should never have to see minified, transpiled, or webpacked production code ever again in our tools when all of these solutions work together. As of Microsoft Edge 1.11, which was available and stable this March, the performance tool now automatically provides the original file and function names while profiling production code as long as source maps are loaded. On this slide, let's compare these two flame charts, both taken from the same point in a performance profile, but one with source maps and one without. You can see in the profile without source maps that there are several instances where we're looking at minified function names. These aren't the functions that you wrote in the source code. They're compiled and renamed with single letter names like M, Y, E, or C. If you have the links to source files preserved via enhanced traces, maybe you might still be able to link back to the production code that the browser received, but it can take some mental gymnastics to unwind the transformations to your JavaScript and understand what is happening in this call stack. By contrast, the flame chart with the source maps loaded is much easier to understand. You can see all of the original function names that called each other, and you can link back to the source map files or the original code in the sources tool. Now, also, as of Microsoft Edge 1.13, which was available and stable just a few weeks ago, we can now leverage your source maps in the memory tool. Object names, when taking a heap snapshot, are no longer minified and will instead map back to the original object names from your source code. And last but certainly not least, we've also landed an update in Microsoft Edge 1.14, where call stacks, when debugging in the sources tool, are now also unminified via your source maps. Microsoft Edge 1.14 should be available in beta at the time of this video's release, and it should be available in stable channel late next week. I'd now like to introduce you to a new Crash Analyzer tool, which is available as an experiment in Microsoft Edge DevTools. With the Crash Analyzer tool, you can input a JavaScript stack trace like those that you get for non-fatal JavaScript exceptions, and have your source maps applied to the stack trace so that you can debug faster. Let's see it in action. For Edge DevTools, we report non-fatal JavaScript exceptions to an internal tool at Microsoft called Watson. This is probably something that you've heard of. You might report similar data to tools like Azure App Insights or another telemetry tool that will allow you to receive these kinds of reports. In this demo, we're going to take the stack trace from one of these exceptions and apply source maps from DevTools source code to it. Here, I'll paste in one of these stack traces into the left pane of Crash Analyzer. Notice that it has a custom section, Source Modules, which has metadata about the JavaScript files that were part of the error. When we activate the analysis after a moment of fetching the source maps from Symbol Server, what you see on the right is the stack trace that references your original code, the file and the function names mapping back to your source files, not the production code that is running in the browser. We can further click through and see the individual stack frames and get to the original source code and see the exact lines that caused the error. To enable this tool in Edge 1.14, launch DevTools, open the Settings tool, go to Experiments, and enable the Crash Analyzer experiment. We're excited to hear what you do with this tool. All right, so that wraps up the features and advancements that we've made in the browser over the past couple of months that can help you debug performance and memory issues. That having been said, we've spent the last year diving deep into web performance at Microsoft, and so we have some learnings about the web platform and anti-patterns that we've noticed that could be slowing down your web applications. One thing we've noticed or observed is that SVG animations can cause abnormally high CPU usage, an unexpected outcome that we were surprised to see, and that caused a bit of work for the web platform team to go investigate and track down. As of the time of this recording, we've seen better performance with CSS animations, and the animations tool in DevTools has much better support for CSS animations than SVG animations. Another issue that the browser runs into is reflow. This is when the browser recalculates the positions and geometries of the elements on the page with the goal of re-rendering part or all of the page. This is a costly operation and can block user input, so you want to minimize using those CSS properties that trigger reflow or changing them. Some CSS properties can actually be handled by the compositor thread instead of the main thread, and so when you do have to change these properties at runtime, the ones that are better to use are those like transform and opacity. So we strongly encourage you to do that. It kind of intuitively makes sense that when you have a large DOM, the browser takes longer to handle DOM mutations or recalculate styles or compute layout, just because there are more elements on the page. When you're using libraries like React that render components for you, we found some techniques like using React fragment or just plain open bracket, close bracket instead of actual elements can improve performance. Another technique that's important is shadow DOM. This is another major functionality of the web platform that we want to call out because it provides containment, meaning that subsets of your DOM can mutate or need to be restyled without affecting all of the other elements outside of that shadow root. Finally, CSS in JS absolutely has some benefits from a developer ergonomics perspective. You can write styles for specific components, you can specify dynamic styles, and it simplifies the amount of things that you have to juggle as a web developer between JavaScript, HTML, and CSS. However, we absolutely have observed poor performance because injecting these styles takes the browser longer to handle than vanilla CSS. We strongly recommend extracting your CSS in JS to a style sheet and then serving that alongside your JavaScript for better performance. Thank you so much for tuning into the Microsoft Edge State of the Web Developer Tools session today. We hope that you found the information that we shared in the session useful, and we're so excited for you to try out these features and send us your feedback. We covered a lot of ground in this session very quickly, so you can find more details and links to documentation, demos, and how to try these features yourself at aka.ms/build-2023-devtools.